Good afternoon. My name is Gonzalo, Yara Ali, and Rafael Ledio. We will be doing the Supermileage project. We will see the objective of this project. The objective of the competition is to provide SAE student member challenging project, allowing practical experimental designing and manufacturing a vehicle, improving fuel efficiency. All the teams have to build a one-person vehicle with a 4-cycle engine. This type of engine is donated by Briggs and Stratton engines. All the vehicles will run a specific course. The vehicle should obtain the best miles per gallon in the competition to win Okay, the requirements are, our requirements are that build a body that should be aerodynamic and lightweight. The transmission should be calculated that permits the engine from a lower RPM. And the engine should be modified in a way that consumes less fuel. Now we will the body design. Rafael Ledio.
Good afternoon. As you can see, for the manufacturing part, first we use this strategy. We will first design the body and drawing. Then we transfer the information to a industrial site who deals with a bigger CNC machine that cuts the wire, that cuts the foam with a hot wire. It's CNC. As you can see here, the wires are very thin, so we put the whole foam mold into the wires, and then we got the sections. Here, they are very thin, so we can see it, but we must have a visualize. You must see that. No. Okay. Now we can see the whole parts cut with the CNC. Then we trace the cross-sectional views from the design of trade. Everything 10 inches, so we get a smooth transition between layers. You can see we trace some wood templates to then.
They were done to produce the front cross-sectional areas of the body.
We trace it, then we apply it to the front and the back part of each part of each cross-section. Then we use the handmade wire. After shaping the mold, we use the base coat or applying it to the mold
to create a gypsum, like it's like a gypsum of the body to work. It's like a mold to work the carbon fiber on it.
And we use the base coat to work on it. So then we shape it. We use the base coat. Then we use a line for the reference to get asymmetrically shaped. Then we use we measure first the carbon layer for the top view and the bottom view. Then we add the resin. You see, it's almost the entire work finished before sanding it. And as you can see, there's a This is the prototype that we use for making the whole body. The finished product, the front view, the back view, and the side view.
Okay, for the transmission design, those were the parts that we used. This is an engine clutch, this is a wheel hub. We will use the wheel hub to put the final drive, that is the 96 tooth sprocket, and we will use this little sprocket to fit it on the keyway shaft. The whole transmission is composed of those parts. You can see here how the assembly begins. We put first the clutch on the engine clutch on the output shaft of the engine. Here you can see for making the way for the sprockets of the transmission, we use a broach to make that way. To then use the key stock to put it on the keyway shaft. As you can see here, there is once at the side of the engine. This is the whole assembly. You have here the keyway shaft, the two sprockets. This is the roller chain, the engine clutch. Also, we use the tensioner to apply adjustment to the roller chain for a better power transfer. Here you can see how it was put the big sprocket on the wheel hub, and here you can see the second tensioner. This is the spring for this tensioner was made to apply and release force to the roller chain. And here we use a idler sprocket. That sprocket was only putting force to a roller chain. Okay, here you can see one of the modifications that we've done. We replaced that tensioner from the other side of the transmission because we were having problems with that, and we get a new one. We built a new one that was fitted, always applying force to the roller chain. These are the new calculations of after the whole modification were done to the engine. Here you can see the power of the engine, new power, and this is the speed of the wheel. Okay, this is the results. We found that at 36,000 RPM, the engine will reach 27.14 miles per hour. But when we test the vehicle gets to 21 miles per hour, having a percent of effort of 12.45.
Well, that's due to the change of the engine. Excuse me? You changed the engine, so
yeah, but
we're basing this
consumption was
the analysis was done with a not modified.
Yeah, the first ones, yeah. But the second one, because we manipulate the speed of the wheel, we will stay at the same range of miles because of the final drive braking. And for the engine modifications, yeah, we did.
After making all the calculations of the engine, taking in mind all the considerations about distance, throw, compression, diameter of piston will be reduced, and the volume, the displacement volume, and the volume.